Hello everyone, welcome to GatePass. In this video, I am going to start taking problems that appeared in GATE 2015 and which were related to thermodynamics. So the first problem, it was very easy. Okay, they have given you that there are three identical closed systems consisting of pure gas, and all three of them go from state 1 at T1 P1 to state 2 at T2 P2. Okay, now they have said which of the following is always true. These three systems, they are going from state 1 to state 2 via three different processes. Okay, now you have to tell which one of them is correct. So it's very simple. Since you are going from one state to another state, so the change in all the state functions will remain the same. Okay, but since your heat transfer and the work done, they are path functions, so they will change. Okay, so let's quickly see. Delta U, delta S, they are state functions, but Q is a path function, so Q will not be the same for all three processes. So option A is not correct. Option B, you have W, which is a path function, so option B is also wrong. Option C, again you see that W appears and Q appears, which are path function, so they are not same for the three processes. Okay, option D, you have delta G, delta U and delta S, all three of them are state functions, so the change in Gibbs free energy, change in internal energy and change in entropy will be the same. Okay, so your option D is correct. Right, so it was a very easy problem. Next, let's move to problem number 6. In this problem, they have given that for a pure liquid, the rate of change of vapor pressure with temperature is 0.1 bar per Kelvin. Okay, now this equation is valid in the temperature range of 300 to 350 Kelvin. Okay, the boiling point of liquid at 2 bar is 320 Kelvin, and they have asked you to find out what will be the temperature at which this liquid will start boiling when kept at 1 bar. Okay, so it's a very easy problem. It just requires only this knowledge of thermodynamics, that a liquid will start boiling when its vapor pressure becomes equal to the external pressure. Okay, so this liquid, it boils at 320 Kelvin because at 320 Kelvin the external pressure is 2 bar, its vapor pressure, which I am denoting as Psat or P saturation. Okay, so the vapor pressure becomes equal to its external pressure. So now what you have to do is that you have to find out what will be the temperature at which the vapor pressure becomes equal to 1 bar. Okay, because this is now the external pressure. When your vapor pressure becomes equal to 1 bar, which is equal to the external pressure, then your liquid will start boiling. Okay, so let's solve this problem. Okay, so what I am going to do is vapor pressure, which I am also referring to as saturation pressure, dPsat. Okay, so I am just going to take it to the other side, integrating it. Okay, so I get saturation pressure or vapor pressure, that is equal to 0.1 T plus some constant. Okay, since I have been given a condition at one point, that is when Psat or vapor pressure that is equal to 2 bar, then my temperature is 320 Kelvin. So I can find out what will be the value of my constant. Okay, and that will be equal to 2 minus 320 into 0.1, that is 32. If I take it to the other side, it will be 2 minus 32. So my C is equal to minus 30. Okay, so I will put this in this equation. So instead of C, I will write minus 30. Now the question is very simple. I have to find out, okay, at what temperature my vapor pressure becomes equal to 1 bar. So I will plug in 1 over here, that is equal to 0.1 into T minus 30. Solve this. 30 plus 1, 31 divided by 0.1, so it is equal to 310 Kelvin, which is the answer. So it's a very simple problem. Okay, so the next problem I am taking is question number 9. They have told you that U, V, S and G, they represent molar properties, that is U is molar internal energy, molar volume, molar entropy and molar Gibbs free energy. Okay, and they have asked you to match the following. So they have given you some partial derivatives and you have to match them what it is equal to. Okay, so what you do is first see over here, this partial derivative is taken off. This is the partial derivative of u with respect to v. This is the partial derivative of u with respect to s. Okay, and the remaining two are the partial derivative of g with respect to p and t respectively. Okay, so that means you have to write equation for du and dg. Okay, so that's what I am going to do. So your du, that is equal to t ds minus p dv. Okay, similarly, what is your g? So I have told you in my very first lecture in this series, that if you want to write it, I have told you a shortcut. So g is the Gibbs free energy, which I have obtained by the Legendre transformation of s to t and v to p. Okay, so the shortcut I told you to write this equation is that you switch the variables and put a negative sign or change the sign. Okay, so then it will be minus s dt plus v dp. Okay, so you have got both the equations. Now let's match these quantities. Okay, so del u by del v at constant s. Let's go to this equation. Del u by del v at constant s. So forget about this. So del u by del v at constant s, that is equal to minus p, or minus sign is over here. So I am matching it with p. Okay. Next is del g by del p at constant t. Del g by del p at constant t, that is equal to v. Next, del g by del t at constant p. Okay, so that is equal to s, and since minus sign is over here, so I am going to match it with s. Del u by del s at constant v. Del u by del s at constant v, it is equal to t. Okay, so we have matched it. P matches with 1, oh sorry, P matches with 2, Q matches with 3, R matches with 4, and S matches with 1. Okay, so if you see over there, then you have option A, which is the correct answer. If you like this video, please don't forget to like and subscribe to my channel, and thanks for watching.